Hi, good morning. I cannot stand behind this podium. Can you see me? Can you hear me well? Thank you, Eric, Gita, and Oded for inviting me here. It's a privilege to be here and honoring Don for 50 years of service, not only to Colombia, but I think to the entire ecosystem, which is connected a little bit to this talk. And also the connection between these three people, Paul, Don, and Kevin, which they are similar, but not very similar. When the first Gita wrote to me that she wants me to give this talk, this is how I felt. Exactly. Because, you see, first Don asked that this would be about research, not about him. So how can I connect the two? I hope I managed to do something, talking more about research, but the problem is that this is 15 years ago, this research, before this colossal amount of data descended on us. So what we can tell now about social networks and social media is much more than what we could tell then. Yet I hope I can add some insights about the community, our community, and a little bit about social networks. So the story begins here. This is the legendary Paul Erdős. He has more paper than Don. He has about 1,500 papers with more than 500 co-authors. But Don has more houses than... and this is relevant. This is relevant because apparently Paul Erdős didn't have an apartment at all. His motto was one roof, one proof. He would go to his colleagues, sit with them, live with them, literally, until a paper would be crafted. And this is how you get 1,500 papers. So maybe Don should decrease the number of houses in the rest of his career. But Paul Erdős was known also for the fact that he started with the Erdős-Renyi research on networks. So he was so good that he also started the network research, but in a mathematical way. Again, it is old stuff, and today we even don't read these papers anymore. Maybe because of his being prolific author, maybe because of this one roof, one proof, his way of life, maybe because he was just good, but they invented the term Erdős number. So if I write a paper, co-author paper with Erdős, and then Peter would co-author paper with me, Peter would have Erdős number 2, I would have Erdős number 1. By the way, my Erdős number is 5, but I believe that some of you have Erdős number that is lower. And those of you who have Erdős number that is too high, you can buy a process where you can decrease your Erdős number. It's on eBay. Because we didn't have data at the time, there was a huge interest not only in the egocentric networks, I'll define it in a minute, but also about scientific collaboration networks. The scientific collaboration networks is just being a node would be an author, and the links would be co-authorship. So each paper you write, you add more and more social ties. This is how it works. If this is Paul or Don, then this is the ego, and all the rest of the authors would be the alters. And then they could co-author, they could collaborate between themselves. And then maybe the co-authors start to collaborate with someone else, and so on and so on. This is not different than a regular network. It is not a way to represent a network as an egocentric network, but it's exactly the same. But it was convenient both because it was easier to develop these networks and also to analyze them. So this term was very common in the end of the 90s. And the most famous egocentric network was the Kevin Bacon. If you participated in a movie with Kevin Bacon, you would have Kevin Bacon number 1 and so on. So, for example, Elaine from Seinfeld, she has Kevin Bacon number 3 because she participated in a movie with Jason Alexander, Constanza from Seinfeld, which he was collaborating with Julia Roberts, and therefore she played with Kevin Bacon. Surprisingly, I also have a Kevin Bacon number. Not very proud with this relationship because this is with this guy. I participated when I was a kid without knowing in a movie. And this is why I have a Kevin Bacon number 4, which is lower than my Erdős number. which means that maybe I'm in a rogue business. But of course, this is nothing. This says nothing about my quality as a researcher because this is a property of the network, not the property of myself. The network is structured in such a way that I'm higher on the Kevin Bacon network. And it's very simple, right? Because if you are in a movie, then you will be like 100 actors there. So you have more ties and more ties. But this is why it was believed that only 6 degrees of separation is the the number of hops that you have to jump between the ego and each and every other person in the network. In fact, the 6 degrees of separation was believed to be the number of hops between any pair in the population on Earth, which is, of course, ridiculous. And then Milgram ran his famous experiments with the letters. People had to send letters to targets, and he measured how many stamps were on the mail, on the envelope. The problem was that this was pretty flawed experiment. I'm not accusing Milgram in anything, but for example, Caucasians had addresses of other Caucasians, and so he separated by ethnicity, by profession, and this was completely flawed. So Duncan Watts decided to repeat this analysis, but he did it now with emails when he was here in Colombia. And what he discovered is that 6 degrees is not the upper bound, but this is the average. So the average number of hops in emails between people would be 6. However, only 0.5% of the emails reach the destination. So this means, and he actually wrote in the paper, by what it was published in Nature, he wrote that people sometimes are reluctant to pay the price, to effort, and therefore some of the chains are disconnected. However, if you take into account the fact that longer chains are more likely to be disconnected, then most likely that this is much more than 6 degrees. Or as Christoph said in his book, so much for the 6 degrees. This is just 0.5%. Nevertheless, it is important to see that there is some correlation between the network structure and how information is disseminated on that. So it's still believed that if a network is dense and close and have a low diameter, then information flies very well on that. There are 2 explanations how come I could have a Kevin Bacon number 4 despite the fact that I'm not in Hollywood. One is the small worlds model by Duncan Watts. It's basically, it says it's like the caveman model. People in Colombia, the Department of Marketing, they work together, they know each other, they collaborated, they exchange information. People in TAC are doing the same, people in Wharton are doing the same, but some people are travelers between the departments, like John Lynch was here, Don Lemon in TAC, and so on. So this is how the network is organized, and information flies very fast. And this is why we can get Kevin Bacon number 4. This is the first model. The second model is the famous scale-free. Most of us have only a few connections. Some of us, like Don, have many connections, and therefore these people are called hubs, and they connect the network. Take them away, and the network is collapsed. These are the 2 models to explain it. So before there was data, there was a high interest in the scientific collaboration, and many fields just generated the same network as we generated in marketing. But they were before us. Mathematics, neuroscience, biology, almost any field created this Erdos kind of. But what is interesting is that they didn't decide who is going to be in the center based on the way that they make the diameter shorter or smaller. We had 2 goals. One goal was to understand how networks are evolving, and we have an advantage because marketing is a very young and small field, and therefore we had information from the beginning, from the 70s, how it grows, while the other networks were based on information when the network was already mature, not like in marketing. This was the first goal. The second goal was to understand how come the network is growing in terms of the number of the authors, yet the diameter is getting smaller. How come we add authors, yet the average number of hops between any pair becomes smaller? Because the number of co-authors didn't increase that much. As a side project, we wanted to understand who should be here. When you check whether, well, it's probably makes sense to put here someone who makes the diameter the shorter possible. So Kevin Bacon it was number 900. There were 899 actors that made the network smaller than Kevin Bacon. They had a problem. The first 50 actors were porn actors. So they couldn't put someone from there. So they decided to go for pretty face, and they chose Kevin Bacon. Not arguing that Don is not pretty, but we prefer to put someone who makes the diameter shorter. Paul Erdős, we don't know why. Maybe he should be the ego. So we ran this calculation to see who is the highest, it is called closest centrality, which is the lower number. Who should be put there to make this diameter shorter? And we, of course, we knew already that some parameters are known, like he has to be someone not too young with more than 2 or 3 papers. He has to be someone, he or she has to be someone who is very prolific, many authors, many co-authors, and also he has to have highest, what we call betweenness centrality. It has to be someone who can work with behavioral people, with quant people, with analytical people, with all of them to bridge all these holes, all these gaps. So we had a small bet, and I don't know if I told you, Don, but my bet was on you. And I won, you already know, and this is why the Lemon number is probably the only network where the ego has the right to be there. The data itself, we collected the data from the 35 top journals, and we looked at all the authors until 2004. Yes, people asked me before, we didn't update the network since then, because again, there's so much better data than this is a good stuff for the 2000, but not more than that. This is the number of the list of the journals. As you can see, most of them are marketing, except JPSP here. It is truncated for some reason, but this is JPSP. Apparently, according to the list, according to the data that we have, JPSP was considered then at least as a marketing journal. And this is the first 10 authors that are supposed to be as the ego. Don came first, after Don was Wayne, and you can see that some of the people are here. Now, it is a good question, and it's too long to discuss maybe over the coffee break. What is the process here? Whether Don pulled these people in, or whether they pushed Don to be up? For this, you need to look at the dynamics. And the history is the following. Vijay Mahajan dominated the 80s, and then Wendy Sarbo took the crown from him for 2 years, only to pass it to Don. We stopped at 2004. However, as you can see, this is only a monotonic and very small decrease. So it gets decreasing. Decreasing is the number of the hops between the pairs. So if this decrease is so slow, if Don never stopped publishing paper, it will be very difficult to replace him. So my bet is still on Don, that he's still the first, but we didn't collect the data, so we don't know. We decided to compare the field with other fields. Sociology, physics, and mathematics were very large data sets and very easy, very available for us, so we compared them. If you look at the number of authors, then you can see, you know what, we don't have too much time, so let's leave sociology aside. This is very interesting what happens there. This is a very fragmented network, and actually they behave as, in terms of authors, very different than what they write inside the papers. They do not collaborate, the clustering is low. You will see that they are very different, but I want to compare it to physics and mathematics. So you see that physics and mathematics is very mature network, and it is very large. Like mathematics is 2 orders of magnitude higher than us. The largest component, I didn't define it, but the largest component is the largest component that connects well. So in marketing, it's 63% of the network. The rest, 40%, are not connected to the giant component. This is how we define. Now, it is interesting that the rest, which is almost half, the largest component of connected researchers there is only 23 researchers. So there are many authors that just published once and either ceased publishing in the leading journals and went down to other journals or switched to a different field. We don't know what exactly happened, but almost 50% of us, they are not connected to the main component. While in physics and mathematics, you see that many more are connected. So this is the formula for the average separation. I think it is clear the average separation in marketing is relatively high, meaning that the diameter is. So despite the fact that physics and mathematics are much larger, the separation is smaller, the diameter is smaller of the network. So it is assumed that the information flies and flows there much faster than in our case. The average number of co-authors, not in a paper, overall, it's very small. People tend to collaborate with their own people. In physics, more than other fields. But in marketing, it's really small. Now, don't consider the people here in this room. It's different, I'll show you the data. But the majority of us, we work with few authors and that's it. And we don't change authors. Another important property in network is what is called the clustering coefficient. How well my co-authors are collaborating between them. So, for example, if I have a paper with Don or Oded, what is the likelihood that I will have also a paper with Kamel? This is a clustering coefficient. Now, there are many ways to model it and calculate it, but the most common one is to count how many triangles you have divided by the number of triplets. That is the common way to do it. So cluster coefficient, it's relatively high in marketing. So it means that if I have a paper with Don, it is likely that I have a paper with Kamel. I'm still begging. Now, what influences the ego? It could be the publication tenure, of course, the number of co-authors, but as I mentioned before, the betweenness centrality, the bridging between other fields is also pretty important, and we wanted to compare. We compared some other factors, but I think this is the most interesting one. There are many ways to calculate it. We use the cross entropy. So if you look at the functions, if you set F2 to be uniform distribution, then the cross entropy would measure what is the distance between your distribution among the journals in the field and the distribution, the uniform distribution. So lower cross entropy means that you are collaborating with other fields, and your cross entropy is low, which meaning that you can reduce the centrality. Reduce meaning reduce the closeness centrality, which is better. So as you can see, if you regress them, that the cross entropy is the dominant factor. So it means that those people in the 10 first authors, like Don, the fact that they are there is mainly because they collaborated with different authors rather than with many authors. If you collaborate with the same authors all the time, then you won't get as high. So we still have the question to answer, and that would be the last in this talk. How come the network grows, yet shrinks? A good proxy for that would be the ratio between the logs of the number of the authors and the number of the co-authors, overall, not in a paper. As you can see, this is the growth in the authors, and it keeps growing, but we stopped at 2004, and it's a serious growth from few co-authors, less than 100, to 1,600. This is just the giant component, not the entire. The entire setup is to 25,000. This is the growth of the number of co-authors, which is very small slope. So if you look at what should happen, it should happen like this, meaning that the centrality, the separation should remain the same with our data. However, what we see is that there is monotonic but continuous decrease. And this is puzzling. It happens in other networks too, but also happens in marketing very strongly. And this is characteristic of the beginning of the evolution of the network. And if you search for the reason, actually, it is interesting. If you look only at the entire population, then you cannot see the rise of the co-authors. But if you look at the top 50 or top 100 or top 200, you will see a serious increase. This means that there is a core in our society, core of authors, that they keep writing papers with different and new co-authors all the time, and they actually are responsible for the fact that the network is shrinking. Shrinking meaning the diameter is closer. Now, if they stop, remove them, remove the 100, then the network collapses and looks like the sociology network, and not connected, and the information doesn't flow. So the question is whether people here and in the field itself, should they write with more and more co-authors? So I would say as a message, maybe this room should collaborate with more and more young researchers only to decrease this. But if you do that, most likely that you'll keep Don still at the top. That's it. Thank you very much.